Welcome, everyone, to episode 50 of the Brandon Adams podcast. I have with me Eric Olson. Eric responded to a tweet I put out yesterday where I was interested in learning about the frontiers of machine learning, specifically machine learning as applied to social sciences. Eric is a Northwestern graduate. He played football there with his co-founder, Christian Salem. He graduated in 2017 with a master's of predictive analytics. He then worked at DraftKings for several years before starting up Consensus. Eric, I'm wondering if you could give us a brief background on your interest in machine learning and on Consensus.
Yeah, thanks for the intro. I guess to start, to give just like a quick top line on what Consensus is we are a new search engine that allows you to type in plain English questions and be returned insights and answers directly from scientific literature. So basically, instead of going to Google and saying, hey, is red wine actually good for my heart, and getting a bunch of editorialized articles, we actually will find the studies that have looked to answer that question and try to pull out the answers for you to make it a easy to use, consumable experience. My background, like you said, I got my master's in predictive analytics from Northwestern. So that's more traditional, just like statistics, data science work. And that led me to a career at DraftKings, where I worked in the analytics department. My role there was the most interesting project, I guess I should say, is I worked on some player profiling initiatives where you take in user bet data and you try to build machine learning models that understand the habits and the skill propensity of certain users. So that's really where I gained some skills and got really interested in giant machine learning systems. None of this was around NLP, natural language processing, which is what we do at Consensus, but it still is kind of under this giant bubble of big machine learning systems that take in inputs and try to predict outputs.
So a lot of listeners of this podcast will not have a strong background in machine learning. If you could just start from the beginning and explain the difference between artificial intelligence and machine learning.
Yeah, happy to. So, I don't want to start and say like all these definitions are like pretty arbitrary for the most part. So like nobody should be thinking like, oh, I'm wrong if I say something is machine learning and artificial intelligence versus one or the other, because generally speaking, all artificial intelligence is machine learning. It's machines that exhibit intelligence like humans, so it's machines learning to do things. The main difference I think you'd like hear people talking about is machine learning would veer more towards like traditional giant statistical modeling, and artificial intelligence would be slightly more complex tasks that may require multiple steps or may have outputs that resemble things that humans would do. But it's, square rectangle kind of deal here.
So when you're sort of playing it safe, machine learning is a good way.
Yeah.
Good terminology.
It's like all artificial intelligence is machine learning at its core. Not everything you'd call machine learning is necessarily artificial intelligence. So, the square rectangle dilemma.
And can you explain what GPT-3 is and also what natural language processing is, generally speaking?
Yeah, I'll try to keep it as high level as possible. So I'll start with natural language processing because GPT-3 is within the field of natural language processing. And like just super simply, natural language processing, you'll hear people refer to it as NLP, is just the field of artificial intelligence that is about understanding, analyzing, and generating text. So it's machines trying to understand text and then do a variety of different tasks with that understanding. Then to zoom in on GPT-3, so GPT-3 is this giant large language model, as they're called, that's been put out by an organization called OpenAI. GPT-3 stands for Generative Pre-trained Transformer, and it's the third iteration. So you get GPT-3. People in this space love their acronyms. Every model and innovation is basically just an acronym of some sort. And basically what it is this So large language models are this new form of NLP models that are trained on giant corpuses of text so that they have a base layer understanding of how human text operates. So I'll go a little bit deeper because I think this is fairly understandable regardless of your expertise level. But basically the way that they understand text, well, first, there's this thing called embeddings, which basically take text and turn them into numerical representations of the text, which then allow machines to understand and process them. So that's like the first thing you kind of have to understand of how this all works. But then how it works more like mechanically is GPT-3 is shown billions and billions of examples of text. So I believe it is trained on basically just like articles on the internet. It's trained on Wikipedia. There's another organization called Common Crawl that basically crawls all pages, like articles and pages across the internet. And then what they do is they mask words. So they blind certain words in these articles. And they basically teach GPT-3 to say, all right, here's a word missing. Here's what comes before it. Here's what comes after it. Predict what that word is. And you show it a bunch of examples of what that word is. And then you have it try to predict that. And then over time, it learns what word is likely to go here, which then informs how to understand the context around things and how to then potentially generate text in the future. That makes sense?
Yes. So it's operating on feedback essentially, but the feedback is kind of algorithmic, whether instead of a human saying, all right, you got it right, they're able to see the actual examples. And
yeah, I mean, that's how all machine learning models are trained, right? You show it examples of things, and then you test it by blinding it. So it is shown examples of text, and then it's what it is trained on to try to be able to do is put text in where there's text missing. So this allows it to have a robust understanding of all of the text around it and trying to understand, the context of language and what makes a word likely to be put in place somewhere.
Now, GPT-3 is natural language processing that is working on text.
Yes.
If you could explain to me intuitively what the difference is between text and voice, and let me explain why I'm asking this. Because when I play around with your consensus search engine, it's very, very impressive. It is giving me search results super quickly, and it's exactly what I'm looking for. However, my 8-year-old son is obsessed with Alexa, loves to ask Alexa questions. And our life is better because Alexa does a so-so job of answering these questions. But yeah, to be honest, I'm shocked that Alexa is not better. So what is lost there? Is voice so much more complicated than text?
I want to first say, like, I'm by no means an expert on voice stuff. My understanding of it is that it is basically exactly the same. It just has the step of trying to understand the voice and then translate that to text. So basically they take what you say and they try to turn it to text, and then it just is NLP going on. And yeah, Alexa is basically trying to find answers like across the internet, right? So a little bit different than what you'd be doing at Consensus, where the only source material is peer-reviewed literature.
I'm also interested in OpenAI and GPT-3. Why did they make this publicly available? Maybe you could explain about OpenAI, the organization. Were they just open source from the start?
Yeah, so again, I do not know all of the ins and outs, so I would encourage anybody to look up things on OpenAI on their own. I believe that they are like a capped for-profit company, and I believe they started as a nonprofit who just was like mission to accelerate the development of humane AI models, and they have since pivoted to for-profit, but they have like a cap on their profits to try to keep their incentives more in line. And it is GPT-3 is freely available if all you're doing it is to play around with it. When you start to be asking it to do big tasks over lots of text, that's where the pricing comes in. So it's priced per token of text that you give it, above 1,000 tokens. So like if you were to use GPT-3 in a production setting as a company over large bits of text data, it would cost you quite a bit of money, actually.
Got it.
They have various like playgrounds that anybody can go into and type in a question and it will generate you an answer.
So it's a for-profit, capped for-profit, and
Yep.
they're sort of on the freemium model with GPT-3, and they might possibly have some hidden versions of like GPT-4 and GPT-5 or something that they're selling or something like this. And companies like Consensus are having to pay some money, presumably.
Yeah. So I can get into the technology we use, but yeah, the probably the application I've seen it the most, there's plenty of other applications, but the application I've seen it the most being used for in companies is for copywriting generation. So it's really, really good at text generation. And basically what these companies do is they have they have products where you can type in like a prompt and like give it some criteria. Like, I want to write a marketing slogan for an advertisement about X with Y tone, and GPT-3 will generate you a bunch of marketing copy. And there's two big companies that do that, Jasper AI and Copy AI. And presumably they would pay OpenAI quite a bit to be able to use GPT-3 so frequently and across so much text.
Now, in the search engine at Consensus, and maybe you could give us a brief overview of Consensus, what parts are sort of off the shelf, if you will, and which parts are ones that are going to have to be fully proprietary capabilities coming from Consensus?
Great question. So yeah, to give you like a super high level understanding, and this also will somewhat explain why we can do what we do so fast, is basically like, you have these hundreds of millions of scientific documents that we have access to. Somebody types in a question, and our goal is to get them insights from papers that are relevant to their question. But we have hundreds of millions of things to do. So if we took it and we ran large language models over all of that at once in a search, it would take forever and it would cost us so much. So basically what you do is you build like a funnel to get you to a likely subset of relevant documents that then you can do some really cool analysis on. So that first part of the wide part of the funnel is pretty out of the box search engine capabilities, where you basically just take in the question, you take the keywords of the question, and you try to say, all right, here's 1,000 papers that may have answers to this question. Then you do a slightly more advanced version where you do some deeper NLP on that subset, and you shrink it down even more to say, now here's 100 papers that are really probably have some answers to this question. And then over that smaller subset, we run what we call claim extraction, where we go through the paper and we try to pull out when authors are stating their claims based on the evidence of the experiment. And we pull those out, and then we re-rank them based on how likely they are to be answering the user's question. So it's kind of this funnel where the top part of it is actually pretty simple, keywording search that can be done in like 0.01 seconds. And it's just like an out of the box solution. And then as the space narrows, it becomes more advanced machine learning, and it becomes more fine-tuned, meaning that it's proprietary stuff that we had to feed the model to teach it how to do these tasks. So models like GPT-3, they come, like I talked about how it was roughly how it was trained to understand language, but then how it becomes a practical application is you do what's called fine tuning. And you basically take this base layer of understanding that GPT-3 has from learning about the entire internet, basically, and then you teach it how to do a specific task with custom additional training data. Does that make sense?
Yeah. So basically, the problem that Consensus is trying to solve is that all of these 0.01 seconds matter, and you're trying to make it as fast as possible. Make it so that you're it's not having to comb all of the hundreds of millions of
pages. Give it a smaller space to run the real advanced stuff over.
So that when the user has a search, it's getting an answer in seconds.
Exactly. And yeah, the 0.01 seconds, I'm pulling that number out of thin air, but it's some very, very tiny amount of runtime that's required when you're doing pretty basic like keyword searching.
Got it. And just so listeners understand, how fast are machines reading? Like if they're looking for one thing in a text, like how fast are they reading? Like if you gave extraneous text that it's never seen before and you're saying digest these 10 million pages, like how long is it taking?
I don't have, there's no like one way to answer that question. And I don't even the certain ways, I don't really have like a great answer for it. So when you say giving it 10 billion thing, like it depends on what we're talking about. So like there's the giving it information in terms of doing the fine tuning yourself, where you're giving it a bunch of examples of the task you want it to do. So to use the copywriting example, presumably what they've done is they get a bunch of marketing copywriters to write marketing copy, and then they have what the inputs are represented for that marketing copy. So it says Facebook ad with a friendly tone for Y product is the input, and then the output is marketing copy, right? It's like with those inputs, you generate marketing copy. And so what those companies presumably did is they had a bunch of people make examples of that with those inputs and those outputs. And then you give that all to GPT-3, and then it learns how to do that task with its base layer of understanding of the internet. And that can take, I don't have numbers, it all depends on how big it is, but those like fine tuning runs can take hours, where it's running through all these different iterations of how to best optimize it. And then once you have that fine tuned model, the input to output can be extremely fast.
Yeah.
Does that make sense? So then in practice, when that now new fine tuned model exists and somebody says Facebook ad, friendly tone, it generates it in like 5 seconds. But all it's ingesting is just the text of the prompts you're giving it, but it's learned on thousands of prompts and then examples of outputs, and learned even before that on the whole internet.
Yeah. Now, let's use an example. Okay, you were an undergrad at Northwestern.
Okay.
Say you were a highly cynical student that wanted an AI engine to write the papers, and say that the teacher said, you're just writing papers on this volume of reading material that I'm going to give you. You don't have to write on things we talk about in class or whatever. Is it at a state, is this natural language processing at a state where it's relatively easy to train the AI given giving these inputs and output comparisons? Like,
yeah, so that's the important
papers. Seeing a bunch of papers that have been written and got A's or whatever, I guess, is a necessary step. But if they have that, are they able to write all your term papers as an undergrad?
Yeah, the given step that you said there is the important piece. So like in practice, it almost would never be worth your time, because presumably you'd have to create the data set of papers for this class, papers around that need to be in a similar structure that have done really well. You need to give it, hundreds or thousands of examples of that. So like, as that is the prerequisite, like you'd have to write those papers to then teach it how to do it. Now, if you could find papers across the internet that are written in a certain way that you think is going to be similar to your class, and you think they're high quality, presumably you could build that system. It's interesting. Again, I gave the example of GPT-3 companies that are content creators, and they're creating marketing copy. And I'm sure you've seen all over Twitter the Dolly example, which is an image generator that uses GPT-3 to take in the prompts. And if you remember like 10 years ago or 15 years ago, when people were hypothesizing about AI, the thing that people always like, oh, what they're going to come last for humans is like content generation and like art and things like that. But in reality, that prediction was actually completely wrong. And it's been the exact opposite. And where we're seeing it show up first in applications is generating art and generating content and writing papers and marketing copy. And I think the reason is because there are less stakes for those outputs, and they're they're not necessarily like right and wrong answers, right? Like art can't be wrong. So it doesn't really matter what it generates when you say, hey, Dolly, write me or generate, a big bald guy standing in a second bedroom that he's turned into an office. And Dolly will generate things kind of like that, but it doesn't really matter what it outputs, right? It's just learning how to do it and spitting it out, and people think it's cool. And then when you think about your example of writing papers, it's kind of somewhere in between, right? Like there's no wrong way to write a paper, but if it's being graded on its quality, the less likely right now it is the GPT-3 or other large language models will be able to do that like as well as a human. But it does, really well with these things that are purely subjective to start. Does that make sense?
Right. And the probability is that they would do sort of one thing over the course of the paper that would give it up, if you will, as not human, like something egregious.
If you spend enough time with these tools, like I feel like I have like a sense, I could predict when something was written by AI and not. I'm sure I'll be totally proven wrong in like, another year from now when there's more innovation, but we did like a press release recently and I saw some other PR like website like reposted it. And I was reading this, I was like, this just feels like this is written not by a human. And I found out that it's an AI PR website that takes a press release and rewrites it as AI. And I was able to like tell that it was just by reading it. And it's just like small things of things that typically humans wouldn't exactly, when their language would be like a little bit different, but it's pretty darn close.
Yeah. Now, I was sort of jokingly saying that the GPT-4, GPT-5 must exist somewhere. But generally speaking, there must be some places where the most advanced machine learning AI capabilities exist that are not currently seen. So I guess some places that come to mind would be sort of Twitter and Facebook internally within those companies. And then you might think like within the military intelligence complex, there might be presumably even the best possible technology. I don't know who would be better, Facebook or the military. And then also in finance, I would imagine that there are some hedge funds that have been investing in this capability for years and probably keep it quiet somehow. Where do you think like the most advanced capability exists?
It's a great question.
And let's say specifically the capability for natural language processing, where you're able to basically very, very quickly take a large amount of text and extract the meaning from it.
It's going to be a boring answer.
Okay.
But the default answer has to still be Google. Because their core product is, a natural language processing product, and it's been that way for a while. And it's, incredible at suggesting questions, and they do some extraction and identification of answers to your questions within articles. Like when you get that featured snippet, like that's fairly similar to what we do at Consensus, just over a different source material. And in some ways, what they are doing is harder because their corpus is the internet. Our corpus is in this kind of sandbox of scientific literature. So I think the default answer has to be a tech company like Google. I know nothing about potential NLP capabilities of government organizations. There isn't an application that like jumps off the page to me where like, oh, I think it's probably there. So like my instant reaction probably has to be with some of these advanced tech companies.
Makes sense. Okay, I have a question specific to Consensus.
Okay.
Just so listeners understand, Consensus is a search engine that you can ask basically anything. You can ask anything in the social sciences or in the sciences, and then get answers from research.
Yep.
And as part of your answer, maybe you can explain how you rank these things, how you weight things such as publication date, number of citations, all of these sorts of things. So you could ask a question like, what is the relationship between budget deficits and inflation? And they will give you stats. Or you could ask any health question or science question. My big question for you is, first of all, how does Google get better over time? Because I'm not sure people generally understand that. And second of all, how does consensus get better over time? As people are asking the same question hundreds of times with slight variations, how is it getting better over time?
Okay, there's a lot there. So first off, to just like address your points about consensus, yeah, I mean, you can ask anything, but if you don't ask about a topic that has likely been studied by researchers, you're not likely to get back good results. So like, it's not meant to be used to type in like, how many people live in Europe? Like that's just a widely known fact that some database has. That's not something that there's going to be a peer-reviewed paper on, right? It's much more for, yeah, does X cause Y? Does this supplement help me sleep? What are the effects of running on damage to my knees? Things like that. To then talk about how these systems get better. So for Google, you know, the thing they're famous for is their PageRank algorithm. So that's how they sort results, is like, given a certain threshold of relevance, they show you the articles that have been clicked on the most. Like that was their big innovation, was basically using their user behavior to then power how the results show up. So theoretically, that's how Google gets better over time. As more people continue to use it, they learn what are the best articles that people keep clicking on, and those will over time continue to be prioritized more and more. And then obviously there's this whole other world of just like feature development, which is kind of outside of the core search algorithm, like adding the the autocorrect and the suggested questions. Those are just like features on top of that core product. In consensus's world, the way that we do not use something like PageRank because we think that's pretty antithetical to what we're trying to do. As Google's is, Google is an advertising based company. So their North Star metric is engagement. The more eyeballs on their pages, the more time you spend in Google, the more ad space they have to sell, and the more money they make. So that means that's why they prioritize popularity and not reputability, right? And there's a reason why if I type something into Google, and you type something into Google, our results will not be the same because they're trying to predict what is most likely to be clicked on and most likely to drive engagement. And we think when you're trying to find answers about important subjects, like things in science, that you can't be using an engine that is set up that way as the North Star metric as engagement. You need to have the same results for all users, and everything needs to be about trying to give you the best information possible. So right now, we basically, the way that I talked about that funnel, to get us to the top 25, which are then reordered purely based on how well they answer the question, we have some weightings on citation count, publication date, and then we also have a weight of what we call like finding quality or claim quality, which is basically the output of the model that predicts where the claims are and tries to extract them, how highly it's scored there, because that's an indicator of how likely this is to be a actual conclusion. Because, we extract sentences from papers that are supposed to be the claims based on the evidence. We inherently are going to end up extracting things that aren't that in our background information. But hopefully, if our model's good enough, those don't score as well when we extract them. So we take that output of like, what is the percentage chance of this being a claim? And we put that into our weighting as well to try to prioritize things that are likely to be actual conclusions. So we have all of that to get us the top 25 that score the highest. And then outside of that, or inside of that 25, we then just do a full reorder based on a fine-tuned question and answer model that tries to just show you which one of these are answers to the actual question. So like a perfect example of this is like, pretend somebody says, what are the benefits of mindfulness? We might extract a claim that says, these results show that there are benefits of mindfulness. On basic keyword and even more advanced natural language processing similarity scores, that's going to score really, really highly. And that may be brought down into our top 25. So what we need on that last step is a more advanced system that is a Q&A system that says, yeah, it's super similar. They didn't even say anything. they didn't provide an answer to the question. You asked, what are the benefits of mindfulness? And all it said are, there are benefits of mindfulness. So we need a system at the end of it to then resort them and say, where is their actual insight to this question? And then try to deliver you those answers. And then to tie it all together of how that gets better over time. So to train that final model, we do examples of question and possible answers, and we have scientists rank them and score them, and so annotate giant data sets of here's a question, here's a possible answer, how good of an answer is this? And we just did a giant exercise of retraining that model with anonymized user search data. So we have, we anonymize all our data. We have no idea who is searching what, but we can see what the questions are. And so we can take all of that data. We can then generate possible results, feed those over to scientists, have them annotate them up and say, this is a good answer, this is not so good answer, and feed that back to our fine-tuned Q&A model that then theoretically over time will do a better job of surfacing relevant insights and answers.
Makes sense. Now, one of the features you have at Consensus is the ability to share.
Yeah.
And I'll explain how that feature works, and then you can tell me if that feeds into the results. Like, are items that are shared more likely to show up in search results in the future? So I recently was in Colorado with some friends for a golf trip, and as it happened, we had listened to the recent episode of the Huberman podcast where he talks about how terrible alcohol is for your health.
Yeah, it was terrifying.
What was that?
It was terrifying. I listened to it too.
Oh yeah. So we were debating that podcast, and I made the case that maybe his claims were not consensus because there is evidence that there are some benefits. And I couldn't really back that up, but the consensus engine is kind of perfect for this because either at dinner or like when you're back from dinner, you can sort of search up health effects of red wine and then get the answers and then email those to friends or what have you. So my question is, if you do that, health effects of red wine, like you're going to get some good answers, then you share one of them with your friends. Does that then play into the search results?
So yeah, to answer that question first, no, it does not. Everything I talked about before is how we prioritize search results. It has nothing to do with the popularity of a result. Again, we don't want to rely on just because people are clicking on it doesn't mean that it is more likely to be an answer to the question. They could be clicking on it because they think it's bogus or some other reason, whatever. We want to prioritize trying to provide insights to the question. But the sharing functionality, yeah, something we're really excited about. Something want to give my co-founder Christian a ton of credit for really pioneering this as something you think could be an important growth channel for us to start. And yeah, I love everything you said, because that kind of argument solver, sitting around a table, talking to friends about a subject and really just wishing in the palm of my hand, I could be like, what does the research actually say about it? That is how I came up with the idea for Consensus. And then to tie it even more all together, Andrew Huberman Lab podcast is a giant inspiration for us. We like to say that he is the human version of Consensus because he does what we want to do, of distilling down research on interesting questions in a consumable way that it can help people and people learn from it. And he is truly incredible at it. And yeah, love that podcast. But yeah, we think searching is great for that reason. Like, you see somebody saying something on Twitter and now you have the ability to look it up in Consensus, reply to a tweet with that finding or that query right in your tweet, share it. People can click on it. You don't even need an account to click on those results and see what they are. So we think it's a really cool ability for people to interact with each other, share the product, win arguments, insert themselves into debates. So yeah, really excited about that sharing feature.
What constraints do copyrights or intellectual property serve for you all? Like, presumably it's just articles and not books for the reason of copyright. Although I don't know, that might be complicated. I remember Google was sort of putting copyrighted material out there in Google Library for a while. So are there certain journals that are like strongly copyrighted? How does the copyright constraint assert itself?
Yeah, I don't know much about the book copywriting system, like the ins and outs of that. Um, but yeah, basically we get all of our data from a research data aggregator called Semantic Scholar. And they are run out of the Allen Institute for Artificial Intelligence in Seattle, which is Paul Allen, the Microsoft founders, artificial intelligence research organization. And they basically, in the same way Google Scholar aggregates a bunch of journals and research papers, they do this as well. They prioritize more open access journals, so journals that you could go to and access yourself, regardless if you have a subscription. However, we do have non-open access journals in our database. It's just if you try to go to the full text from Consensus, you will then hit the paywall. So basically, we have a license and a partnership with this data aggregator, which gives us access to these papers to run our analysis over. But if you try to go and access the full text yourself, you would not be able to. You'd be subject to all of the, or for some of the articles, you'd be subject to the paywalls of those places. Good
Yeah,
news is
I
though,
experienced that.
yeah, the good news is the trend is on our side here. And open access and open science is a movement that has so much steam. And I don't know if you saw, but there was some legislature about like 3 or 4 weeks ago where I forget by what date, but by some date in the near future, all scientific papers that have been funded by federal dollars have to be made open access, which is the way that it should have been the whole time. But there's going to only continue to be more and more open access papers that anybody can access themselves.
That's interesting.
Yeah.
So tell me, like, when you're seeking out expertise, when you've got a hard natural language processing problem that you're trying to solve at Consensus,
Yeah.
where do you go for that expertise? Where does it exist? Is it in universities? Is it just ex-Google employees? Is it consulting companies? Like, where do you go to find the frontier?
Yeah. Great question. And it's an interesting subject because it's pretty new. And these large language models like GPT-3 are only been around for like single digit years, right? So like it is all new. So it is not the most straightforward answer to say where's the expertise here. For us at Consensus, we've been lucky enough to hire an amazing team, and um, our two machine learning engineers. One of them, Ali Fareed, has a PhD in computer science and in university studied things about natural language processing. So that's kind of coming from academia angle. And then our other machine learning engineer, Brett Nebeker, he actually came from a company that was doing NLP on law documents. So it's actually like an even earlier application of NLP before GPT-3 or anything like that, where machines basically look through the text of a law document and try to classify sentences as, I believe, like privileged or non-privileged material, and I'm sure a bunch of other stuff too. But that's the example he used to give us. So he actually learned all of this mostly in industry for an earlier application of NLP. So I'd say the two places there really is true expertise is at companies that were early adopters of NLP or in university from a more theoretical perspective. And then the other way that at Consensus we get expertise is we've been lucky enough to bring on an awesome advisory board, which one particular guy is a true expert in this space. His name's Conrad Cording, and he's a professor at University of Pennsylvania, and he's a world leader in deep learning and machine learning. And he actually wrote a paper that was part of the inspiration for Consensus. So he wrote a paper about how to extract claims from scientific papers. And that is a lot of the scaffolding that we use to build our first version. And we reached out to him, and we were lucky enough, he has an equity stake in the company and helps us with a lot of these problems. And that's a pretty good example of the knowledge coming from academia first, because they were just doing this from like a theoretical, not theoretical, they did do it, but they were doing it with like a research lens. And then we come about the paper and we take it and try to make it into a product application.
From the top-down perspective, if someone came to you and they said, what is the best book or survey article that I could read to get an understanding of modern language processing, where would you point them?
I wish I had a better answer for that. I'd want to ask our engineers. They probably would have a way better answer for me. I would say read anything that OpenAI has had their hands on. So they've published scientific articles themselves about GPT-3 and similar things that you can read. And I think that, they've probably been interviewed in a bunch of articles and maybe written some articles themselves. So I would use that as kind of your anchor point for finding reputable content, is find things that OpenAI has had their hands on, and they have a lot of documentation of all these models. That makes you get into the weeds a little bit more, but if you already have a base layer understanding or feel like you've read some and then you have, yeah, you can even look into some of the documentation of all these models and their capabilities.
What do you think of the future of journalism? There was some quick Twitter conversation I came upon about a Scientific American article that just came out where AI is supposed to write an article about itself, like AI is writing an article about AI, and it's supposed to be like convincingly human. I didn't get a chance to dive in, so I can't really say much about it, but it sort of begs the question. In journalism, a lot of what's happening is kind of synthesis of what's out there already, right? So is the future of journalism AI and machine journalism, machine learning generated text?
There's some companies already, I believe, starting to attack this. And it's gonna be kind of similar to that like student paper example. Like the high level answer is like it definitely would already be able to do this if you gave it the right fine tuning data. How it will actually, but the real limitation of some of this generative GPT-3 is a generative model. It takes in an input and generates you an output. And the real limitations of it is, as it stands now, there definitely are going to be ways to around this in the future, is it doesn't cite its sources, right? Like what it generates is kind of effectively from thin air. It's what it's learned about. It comes in principle from what it's learned about, but you don't get to say, if you're writing an article about a given thing and you're citing either studies or previous articles or a quote from whatever, like if GPT-3 generated you an example, you have no ability to do that. And what it spit out is effectively just from thin air as far as you're concerned. So I think that's a real limitation in how it would be applied to writing like a rigorous article. But where I think we'll probably see it first is like generating top line summaries for journalists. So like a journalist writes an article, you run GPT-3 and then you have it generate you the most, grabby headline, 2 sentences that you can like put on the top of your article as a summary. That would be able to be done like right now. And I'd be shocked if there aren't companies trying to do that. So there's some limitations for how it could actually write. It definitely can write articles already. You probably could tell it was written by an AI, and you'd have a limited ability to cite sources. So I think those would probably be the 2 limitations before, there's just no journalists. But I'd be shocked if we don't see it doing some tasks for journalists in generative text.
Football fans, join the next generation of fantasy football with Rainmakers Football, the first ever NFT fantasy game from DraftKings. It's the only NFT fantasy game licensed by the NFL Players Association. You can play all season for millions in prizes by building the ultimate NFT franchise. Playing Rainmakers is simple. Buy, sell, bid, and win player card NFTs of the biggest names in the game through regular drops and auctions on DraftKings Marketplace. Build your NFT franchise and enter free Rainmakers football contests all season long. You'll be competing for almost $30 million in prizes. Download the DraftKings Fantasy app and sign up with the promo code ADAMS. Click the Rainmakers tile and opt in to get your first card free. You will then be playing for millions in prizes all football season while building the ultimate NFT franchise. That's promo code ADAMS. Build, play, and win only at DraftKings.
So in terms of finance and sports being sort of frontier, I would really think of finance as being the place where this stuff is likely at the frontier, just because the timely, extremely rapid digestion of value relevant information is so richly rewarded, right? That I would think that these natural language processing models are already existing somewhere. They're just sort of secret, So I'd be curious how those might work. I would think that whenever you have an expectation structure that you're dealing with, it's got to get very complicated, right? Because let's just say it's sports and people are really interested in how many rushing attempts is Cam Akers going to get, and they know it's coming right down to the wire, and they have to interpret things like, okay, what's happening on the practice field and who's talking to who on the sidelines, and like all these conversations that are somewhere in the Twitter sphere or from beat reporters. And you have kind of the expectation structure, and then you're evaluating news on the basis of the expectations. Or to put a finance example on it, you have, I don't know, some Fed comments coming out, and you have an expectation about what the Fed's going to do in the future, and then you're revising that expectation based on the language that's being used. That must be, yeah, but that must be like an extremely complicated problem. Do you think that this is something that people are making progress on, or it's just sort of too complex for machines at this point?
I definitely think it's something people are making progress on. I think there's a ton of reasons why financial institutions don't have the capabilities to do this. So my guess would be that this will come from the outside. So I'll start with the finance example. I think that's a great future use case, and in a lot of ways has some similarity to what we do at Consensus, because one of the benefits we have at Consensus is it's kind of counterintuitive, because science is like super duper complex and whatnot, and there's so much nuance, but the way that these documents are written are extremely structured, and that allows for large scale text analysis, right? Like they're written, here's the introduction, here's the methods, here's the objectives, here's the results, and allows machines some scaffolding to pull out information. And I'm not a financial expert, but I imagine that financial white papers or earning statements or Fed comments, those documents could have similar qualities, where it allows you to kind of play in the sandbox of the structure of documents. And as long as those documents have useful insights and you want them quickly and at scale, I see no reason why you couldn't build something similar for financial documents for financial institutions. We've talked about that as a future 5-year vision for Consensus. We're not doing that right now, but in theory, you could do some of the same practices. In sports, yeah, the use case is a little less clear to me. Maybe you could train a NLP model to read tweets from Schefter or Shams, and try to assess the likelihood of somebody to play based on the sentiment of the tweet, that then can inform some DFS or gambling decisions or something. But yeah, probably a little less clear in my eyes for the sports application.
Now, in terms of sort of personal assistant or whatever, what's necessary is for you to provide feedback to the machine learning model, for you to teach it in some way, right? And it would seem like personal assistant use would be one where you could provide feedback, because, for instance, down the road, if you had, let's just say, I'm not getting so many emails, but there are people out there getting hundreds of emails per day that they can't possibly respond as a single person.
Yeah.
If they had the machine reply for them, they could presumably teach the machine when the machine was giving a good response versus bad, and then they're learning over time. So for instance, the machine consults your calendar and sees that you're not available. Brandon is not available on that day. And then you sort of teach, is that a good response or a bad response? Is that a likely application of natural language processing in the future?
100%. And the example I'd give to back that up is, everyone is pretty familiar with, these new models are new. They've only been around for single digit years, but NLP has been around for quite a bit longer. And an application that almost everyone's familiar with, an application of NLP that's been around for decades is chatbots, which effectively what you're talking about is a more advanced chatbot, where you go to customer support and there's a machine talking to you about your problems and then replying to you. And there's no that many fundamental differences between that and what you're talking about, where it takes in a prompt, a question from somebody externally, and it tries to provide a good answer that is correct about the source material. So you're on DraftKings and you go to you type in a customer support ticket. There's an automated system that's like, what can I help you with today? And the user types something in, and then given what they said, it will provide you with a response to that. And that's effectively the same thing as like a personal assistant that would be replying to emails.
And when you're giving feedback to the machines, is it really just yes, no? Is it like when you're getting results for a consensus search, is it really just yes, no, this is not what I want, yes? Like, is it just the yes, no, or is the feedback more complicated than that?
Yeah, good question. It can be more complicated than that, and it just depends on the task you're doing. If your task can be boiled down to a yes, no, then being able to provide it with just a binary outcome, you'll get the best accuracy. Problem is, not all tasks can be boiled down to a yes, no. And even a task like ours that is question answer, we wanted to have a little more nuance on there that gives it an ability to like write it as like a little more scalar system, where it's not just this is good, this is bad, because there's a lot of nuance to it. Like it could be totally relevant, but just like slightly adjacent question. Like we want that to be shown differently to our model than something that's just completely irrelevant. So there is tons of ability to make these input systems more complex. And in as like these examples we're giving about like prompts in generation. So you can think of the copywriting example I gave, or this email example I gave. The way you would train those models isn't by giving it like yes, no, this is what you should do, this is what you shouldn't do. It's giving it examples just of what it should do. Of you basically feed the model, here is prompt, here is what we want you to say, and you give it thousands of different examples of that. And so it's actually learning from response pairs and how to formulate response pairs, as opposed to just like thumbs up, thumbs down. Does that make sense?
Yeah. Now, how did you all settle on one sentence as sort of the abstract from a journal article, the one sentence summary?
Yeah.
And is that something that is a changeable thing? Like, is it,
yeah.
let's say you got a massive sort of VC round tomorrow, and they said, okay, just one thing, Eric, like we need to have 3 sentences for each paper. And unless you can come up with an amazing reason why it's not 3 sentences, is that something that could change really quickly? Or is it sort of just one sentence as crucial to the construction?
So an important point here about what we do is that I've talked a lot about GPT-3 and generation. We actually don't generate the text. We extract the text. And we think that's really important for our use case, because we want to make sure we're delivering correct information that represents what the scientists are saying. And if you take in a bunch of text and try to spit out just one sentence, there is still a lot of room for generative models to pervert the meaning. And when you're dealing with things that have consequences, like the results of scientific studies, we wanted to extract the sentences and not actually generate them. And that is kind of the answer for the single sentence. Is we want to try to preserve all the meaning of what the scientists are saying. So allowing us to work in these sentence units is the best road to delivering those type of results. However, there is, we're working on things right now to add additional context to the sentences where they're not, sometimes you can write a sentence and it doesn't make sense on its own. We want to be able to pull in other information from the paper and tag it onto the sentence for it to make sense. And in theory, you could build that out even more and have it be multi-sentence. Like you're saying, if we wanted to make our results be multiple sentences, we could do something like that. But we're trying as best we can to do as little of generation as possible. For the exact reason that I talked about, when you asked me that journalist question of the limitation being the citing of the source. We want to be able to attach these sentences to where they came from and keep the meaning of what they're saying, to say, here's what this author said from this paper, and here is that sentence, and here is that paper. That's really important to what we're doing. So again, we want to, as much as we can, stay away from abstractive generation.
That makes sense. But yet, like, the next generation of machine learning would be like a more advanced form of
generation.
consensus. What's that?
Where you generate and GPT-3 cites its sources. How cool would that be?
Yeah. Oh, so explain how that would work.
Don't know exactly. This doesn't exist yet, but you in theory could try to train a specific type, a fine-tuned version of GPT-3 that is both like extractive and abstractive, where it could extract things from a few papers and then generate a summary across those papers and into like a one sentence, and then have it also spit out, here are the 5 papers that I generated this from. So effectively, it is GPT-3 citing its own sources.
Right. Right. And then kind of the next generation from that would be a lot of the questions you're asking. It's sort of like you're asking for a consensus coefficient, if you will. So if I'm asking it, what is the relationship between money supply and inflation, I'm sort of asking an empirical question about coefficients. Yeah. And it could kind of
synthesize it.
Yeah, be able to say, all right, 5% increase on average generates this change in inflation 3 years from now or something. And health a lot of times is also kind of risk coefficients, right? Non-smoker versus smoker in terms of cancer risk 5 years down the road, drinker versus non-drinker, exercise versus non-exercise. Like, it's a lot about coefficient estimates, and the consensus that you're interested in is like, what is the coefficient?
100%. This is actually what we pitched as our initial vision, and this is what we want to work toward, is a synthesis across papers. We want it to still be tied to these, being able to cite where they came from, so you can always access the source material. But the name of our company is Consensus for a reason, right? We want to eventually get to multi-paper synthesis, where you can type in a question like that, and it will say, like, here's 7 papers that the average of the responses was 5% increase in money supply or whatever. That is what we want to get to. It's a extremely difficult machine learning problem. We know how we want to attack it, and we're actively working on it.
Now, maybe you could explain a little bit more about the consensus model as a company before we go. I'm particularly interested in the business side of it. There's no revenue model, seemingly. You can play around with the product, and it's sort of like, wow, my life is better for this existing, but how am I going to channel some money to them?
Yeah, no, great question. So for everyone out there, if you go to consensus.app, you can create a free account and start searching right away. And our model, for the future, is going to be a freemium subscription model. So we want to be able to give people some free access to the product. Exactly how we, divvy up the paywall versus not is still kind of TBD. Our focus right now is getting out there and growing and getting in the hands of users and getting a bunch of feedback and making the product better. And then when we feel it's time, we'll put a paywall somewhere. Hopefully what you use now will always be free, and it'll be the premium features that we create in the future that will be paywalled. But there's also a world where we do some, usage-based. You have 3 free queries, and after that you pay us. Don't hold me to these numbers. I'm making them up. You pay us $7.99 a month for a subscription to Consensus. And again, going back to talking about Google, we think that it is impossible for a company like us to exist with an advertising-based model. I know our ethics at our heart, and I know we want to do this the right way and deliver good information, but incentives run the world. And as much as I say I want to do the right thing, if my company is set up in a way where I make the most money by keeping people the most engaged and keeping them clicking, then I won't build the version of consensus that needs to be built. We need to be incentivized to deliver you the correct and good information, not incentivized to keep you engaged in the product. So we will never operate as an advertising-based business, and we think we have to be a subscription revenue model.
I love it. Eric, thanks so much for the time. This has been great.
Yeah, it's been a ton of fun. Thank you so much for having me, Brandon.